Hello and welcome to the second video of our series, Vibration Diagnostics for Beginners. In this video, I will simply explain how to start your predictive maintenance. You need to consider which machines are critical for your factory's production. These critical machines should have the greatest priority over the other machinery, and you should also consider how much time you can spend on measuring them regularly. It is ideal to measure the machines every week, but we're not living in an ideal world. Despite that, try to schedule measurement of those particular machines at least once a month. If you plan to measure your machinery every half a year, please turn off this video now and throw your vibration meter or analyzer into the trash. It does not make any sense to measure with such a huge time span. It would not be predictive maintenance, but the run to failure method. Imagine how many things can happen during half a year. Let's explain what the basic vibration measuring equipment looks like. It consists of the following parts: a vibration meter or analyzer, a cable, an acceleration or vibration sensor with a magnetic base. How does it work? You place the acceleration sensor on the measuring point. This converts the vibrations into electronic signals. The signals are transmitted via the cable to the vibration meter or analyzer, and the signal is processed into the vibration values which you can read on the device screen. The measurement point is the place on the machine, usually a bearing housing, where you place the vibration sensor and where you take your vibration measurement. The measurement point location must enable you to take repeatable measurements under the same conditions every time. Measurement repeatability is very important. How to prepare the measuring point? To obtain quality and repeatable measurements, you should prepare your measuring point on the bearing housing. The best way to do this is to fit all measurement points with measurement pads. A measurement pad has a flat ground surface made of magnetic stainless steel, and it is connected to the machine with a special glue which has metallic properties when dry. This ensures good vibration transmission. An acceleration sensor is usually supplied with a strong neodymium magnetic base, which ensures good transfer of machine vibrations to the sensor. So, the ideal measurement point solution is glued measurement pad, magnetic base, acceleration sensor. For mounting the measurement pad, it is important to clean the machine surface. This means removing paint and rust with a grinder and degreasing with solvent. Then cut the glue. Mix the two glue components between your fingers. Glue the pad. After 24 hours, the pad is ready to use. Avoid just placing the sensor on the bearing housing without the glue. The flat magnetic base will rock on the rounded housing surface, and such a measurement is useless. If you don't want to glue measurement pads on your bearing housings, then you can use a magnetic base for curved surfaces. The disadvantage is that such a magnetic base has a little bit worse transmission of high-frequency vibrations. As you know from the first video, this means mostly bearing vibrations. Do not measure on motor fan covers. Fan covers are weak and they don't transmit the real vibrations of the machine. Bearing vibrations are not there at all. Do not measure on rusty or painted, or both, bearing housings. Rust and paint significantly dampen high-frequency vibration transmission. The direction of the measurement point, this means radial and axial according to shaft rotation, is important as well. In an ideal world, you would measure in a vertical radial direction and a horizontal radial direction on each part of the machine. But then you will spend twice as much time on each machine to collect the data. Let's make a compromise. Place the measurement point or sensor at 45 degrees, if possible, in a radial position. You will still have information about both vertical and horizontal directions, and you will spend less time on the machine. You should also measure one axial point. Don't measure the axial direction on the motor non-drive end, but measure it near some joints of individual components, for example near couplings. You can use a triaxial sensor for measuring all three directions in one step, but for basic condition monitoring, measurement on one radial point is sufficient.